today I'll be giving a quick talk about KokkosComm, which is an explicit communications API for Kokkos. So just a disclaimer, this talk happened because I volunteered to give it. I don't actually work on KokkosComm. These are the people who actually work on it. But I will give this talk. So there's some points of contact. If you want more information, definitely talk to Carl Pearson or Cedric Chevalier, or join the Slack channel. There's a MPI interop channel. Okay, so a little bit of motivation here. So I'm sure that everyone who's written a Kokkos application that's using MPI has written something like this. Like you have a view, doing some operation on that view, and you want to send it to another rank. So you just call your MPI isend here, give it the view.data, and so on. Hopefully your type is like one of the MPI types there. Not you have to do a little bit more work. Okay. So it's kind of annoying, but not too bad. But okay, let's say you're writing like some sort of stencil application here, and now you only want to communicate the boundaries of your cell. So just the part that's going to be used for the actual stencil computation. So you're like, okay, well, we'll create like a subview of the cell. And then we start running into issues because like with this assert here, you can see that, Christian, I think your adapter is subpar. Okay, yeah, well, let's keep going and see what happens. Okay, yeah, so then we go ahead and, I'll just use this as backup, thank you. We go ahead and we're going to communicate this boundary, and this is immediately a problem because this boundary is not contiguous. So you're actually going to just, like this will actually compile. You'll just get the wrong data just because you're calling the boundary.data, and yeah, you're not going to get what's actually in the boundary there. Yeah, so that's not great. So kind of the quote correct way of doing this. You go ahead and, oh my God. All right, one moment, technical difficulties. Yay, okay, all right. Surely this will get better. Okay, yeah, so the quote proper way of doing this is you just go ahead and create another view. This one is just gonna be like a block of memory that's the size of your stencil boundary. Then you have to do a deep copy. So you're going to copy all of your boundary data over. And then because this new view is contiguous, you can go ahead and do an MPI send, and that should be fine. Well, it's fine unless you have a scope, like this isn't a function or something. You've just done an isend, and then your temporary view will, at the end of the scope, it will get deallocated, and who knows when the send is actually going to do the send. So it's going to be a use after free, and your program will hopefully crash. If it doesn't crash, then you have worse problems to deal with. Okay, so clearly this is not particularly straightforward, simple. There's a lot of things you have to worry about if you have anything more than just like a very basic Kokkos application. I haven't even talked about views that are on the GPU. So like if you have a GPU view, you're going to have to copy it over to maybe like a CPU buffer unless you have an MPI that is GPU aware. Okay, so here's kind of the easy version of all of this. You go ahead and use a fun library called KokkosComm, and I just grayed out all of the setup stuff, and you just at some point you have a handle that has the MPI communicator and so on it, and you just call KokkosComm : send. Give it the handle, give it your boundary view, and give it the destination rank, and everything is pretty much as you would hope it would be. So yes, so KokkosComm. Right now it's kind of in an experimental stage. It provides MPI interfaces and more for the Kokkos C++ performance portability programming ecosystem. And the main idea behind it is it kind of creates a single implementation that does all of the things that everyone has to do at some point if they're using MPI and Kokkos, but does it correctly. So you can find it at that GitHub URL. The QR code just leads to the exact same thing. And supports, mostly right now, it supports non-blocking point-to-point. So I used iSend in examples. It pretty much is an iSend for most of the operations. And there's some collectives that it can do right now. Not all of them are non-blocking. So some of this is still a work in progress. Yeah, as I mentioned, that this is asynchronous by design. So here's an example of a point-to-point usage here. So on the left, you have the sender. On the right, you have the receiving rank. And yeah, again, you create this handle. You have a non-blocking send, so you can queue up like multiple sends. And the nice thing is if these views are like not contiguous, it's going to keep a temporary view and a buffer around. And it's going to make sure it tracks the lifetime of all of this. And then you can go ahead and whenever you need to wait for these operations complete, you just have the KokkosComm wait. And the same thing on the receive side. So what is KokkosComm doing under the hood? So as I mentioned, it does some staging. So if you have a view that exists in the device memory space, like a CUDA space, then if the communicator is not back into where, it's going to stage it to a host buffer before sending it. It also keeps track of the lifetime, so all of these temporary buffers, it's going to keep these views sort of in memory, like keep references to them until the operation has completed. And then it's also going to do the packing of non-contiguous views. So the example that I showed at the beginning where you had to do this whole deep copy, it handles all of that for you. And it happens in the same space, memory space as the original view. So another fun feature of KokkosComm is that it also has experimental nickel support. It's still in its early stage, so I can't emphasize this enough. It's an experimental library. This is an experimental feature of an experimental library. But basically, so the setup is a little bit gnarly. You have to kind of like you have to call some nickel stuff directly first, but then yeah, so you can just use it as you expect here, and even shows off the all reduce here. All right, so just to wrap everything up, KokkosComm provides a generic asynchronous interface for communicating Kokkos views in distributed applications. It's still pretty early in the development stage, but we think that it is in a good place for people to try out and also to get feedback for. So any feedback is very much appreciated. As I mentioned, it's still missing some features. Like there's some, like not all of the collective calls are support non-contiguous views, and some are also blocking right now. But this is still stuff that's being actively developed. So yeah, there's also thinking about more communication backends just besides just MPI and Nickel. And actually, I did the slide yesterday because somebody already opened a pull request to add RCCL support. So I just added that little thank you to them. Of course, it will be reviewed and potentially merged in. So anyway, that's it for me. Yeah, if there's any questions, I'll try and answer them. If not, I will try and forward them to the developers. So.
Thank you, Nick. We do have time for a couple of questions.
Do you have any indication if Nickel or Rickle will be faster than MPI?
So I believe, so what I was told that at least like in some of the experiments they're doing, at least with, that Nickel actually had a pretty significant performance benefit. I don't have any numbers to show you. This was just kind of word of mouth. So it remains to be seen like for like more empirical evidence, but yeah.
Yeah, also questions on Nickel. So is that something where, yeah, can you go back to that? So the all reduce, right, like that's, that looks like, you don't need to, you could run it either with MPI or with Nickel, right? Mm-hmm. Do you feel that that would be true for all the operations, or is that a thing where like you would be able to mix MPI and Nickel stuff, or
okay, yeah. So
how do you think that works?
The mixing MPI and Nickel, I can't answer. Probably is something to ask Carl. But so my understanding right now is that so this this particular interface is, could be, is generic across the backend. So, this works the same with MPI or Nickel. There's like a lower level interface. I haven't really touched upon it at all, but like for like MPI specific operations, and that supports more collectives. But those are not in like the general namespaces, like a KokkosComm : MPI namespace. So that's a little bit more than I've covered actually.
So for the Nickel backend NDR, it's string-based, so technically you don't need internal fence. But for MPI, do you need fence internally before operation starts?
So I think you would. Well, no, I don't think you need a. I don't think you need a fence because I believe that the send operations will essentially call fence beforehand. Or it will be implicitly as part of the deep copy.
All right, any more questions? If not, let's thank Nick again. Oh, sorry.
With the regular MPI stuff, do you know if they try to use, I don't remember the MPI nomenclature, the fancy data type where you specify strides instead of ourselves packing it? Do you know if they tried that?
I don't know that. Sorry. Yeah, definitely ask Carl that.
All right, if there's nothing, there is one.
Two questions. So I know that like you're not equipped to answer on like if Nickel and MPI can be mixed, but are the backends able to be compiled at the same time?
I think so. So like in general, when you're specifying that handle, you're actually giving it sort of like a communication space. So like there's specifically like a Nickel communication space and then a MPI communication space. And so I believe that, yeah, they can be compiled together.
Right, so there's no restriction for like, you can't compile like CUDA and HIP at the same time in Kokkos, right? So like, it's not like that.
Yeah, it's not like that as far as I know.
Okay, and then you might not be equipped to answer like for the wait operation, is it waiting for your view to be done being used by the internals of the library, or is it waiting until the operation is reported as complete by the backend?
So I believe that it's when the operation is complete, because like once essentially it does like a MPI wait, and so once that is complete, then you can safely dereference the view. So like you can let it go out of scope. I think like I was talking to Carl, and like I guess like a question that you might follow up with would be, like, is this thing allocating a view every time that you're calling a send? And right now that is the case, but they're looking at potentially like caching that allocation and reusing those temporary views.
Oh, okay. So if what if there's no work? Like, what if the data is already contiguous? Is it still going to make something it's still going to make a temporary buffer?
No, it doesn't. But like, it can still keep a reference to that view, so that like even if you're like not using that view anymore, it's not going to go out of scope while the operation is still pending.
Okay, thank you.
All right, then let's thank Nick again. And next up is Matt.